From aliens to supernovas, astronomy is awesome, especially when the deep unknown can be peered into. The Sumerians, from modern-day southern Iraq, were recording constellations and star positions over 5,000 years ago. But when you're dealing with light years, the distance light travels in a year, 9 trillion kilometers, things become difficult. Juno, a NASA space probe which travels at 175,000 miles per hour, can't even make it to the nearest galaxy. So how can we see billions of light years away? Isaac Newton's improvement of the telescope had a real simple design. Light would come in and bounce off a concave mirror at the back, which focused incoming light on a smaller mirror that directed the image into an eyepiece. Since it used mirrors and not prisms, the telescope had undistorted colors, and Isaac Newton was ushered into the Royal Society of London. But modern telescopes are far more advanced. Even though the Hubble Space Telescope, launched in 1990, has the same basic design as Newton's reflecting telescope, it can generate pictures of space 15 billion light years away with visible infrared and ultraviolet cameras. This is because the Hubble Space Telescope orbits outside the Earth's atmosphere, which distorts incoming light, and because the telescope takes many pictures with different focuses and angles over long periods of time to construct images. See, light coming from 15 billion light years away won't always give such an accurate picture of distant objects unless it's sorted correctly. After taking its pictures, the Hubble Space Telescope sends them back to Earth via radio waves. Of course, since some pictures came from areas over 10 billion light years away, these areas may look totally different in actuality due to the time it took for the light to reach the telescope. But here's where it gets really cool. After Einstein showed us mass could redirect light, astronomers found something amazing. A nearby pileup of colliding galaxies which had enough mass to take light from far, far away and focus it, just like a magnifying lens. It's called Abell 2744, and astronomers use it to find the oldest known galaxies. There are even space probes like Gaia, launched by the European Space Agency in 2013, which map out the position, composition, temperature, and movement of stars. Gaia will do this for over 1 billion stars within its 6-year voyage. Radar, infrared, ultraviolet, radio, and gamma-ray astronomy also exist, all to be able to record images, heat, and composition of distant objects better. Nevertheless, for space observation and exploration, the limits really are endless.